Before the 1700s, human society was hard-capped by a strict biological limit. Every society relied entirely on surface-level organic energy. Wood was the universal legacy tech. It served as the sole bottleneck for human expansion because it had to function as the primary fuel source, the primary building material, and the primary resource for tools. By the mid-1500s, Great Britain's rapidly growing population hit the ceiling of what the surface could provide. They were consuming timber faster than the land could regenerate it, triggering widespread systemic deforestation. To resolve the crisis, Britain bypassed the surface entirely. They pivoted to subterranean energy in the form of coal. Coal offered a massive resource buff. As a fossil fuel, it provided a seemingly unlimited quantity of dense energy output. The surface area limit was gone. There was only one catch. That energy was locked deep underground. Accessing it and putting it to work required an entirely new hardware architecture that did not yet exist. Hitting a hard biological wall forced a mandatory system update. Society had to transition from a surface harvesting economy to a subterranean extraction economy. Identifying a new energy source is only half the equation. To operate the complex extraction hardware, you need a massive, readily available human labor pool. This requirement was met by the 18th century agricultural revolution, a strict prerequisite to industrialization. British agriculture received several critical upgrades: the physical expansion of farmland, improved methods for crop storage, and high-yield crops like the potato. This animated line graph shows the immediate result of those upgrades. By increasing the food supply, ordinary families could feed themselves with far less labor, dropping costs and allowing a healthier population to surge upward. Families suddenly had excess income, which created a fresh domestic market eager to purchase manufactured goods. But the system still required bodies inside factories. Parliament provided the push by passing the enclosure movement laws, allowing landowners to aggressively fence off common agricultural lands. This map of Britain shows how that physical fencing forced landless workers to abandon the countryside. They migrated heavily into cities, generating a highly condensed supply of labor specifically for factories. By simultaneously securing an unlimited subterranean energy source and artificially generating an urbanized labor surplus, Britain secured the ultimate first-mover advantage. The primary hardware leap enabling coal's industrial application was James Watt's improved steam engine. Its core mechanic converts thermal energy from burning coal into continuous mechanical work. Watt modified it to drive large-scale machinery, converting vertical pumping into rotational force. This broke the geographic limits of manufacturing. Prior to Watt, pre-industrial mills were entirely tethered to fast-flowing rivers to generate water power. With steam engines running on transportable coal, factories no longer needed to be near streams. They could be dropped directly into dense urban population centers. This created the ultimate industrial feedback loop. Initially, the primary job of the steam engine was pumping water out of deep coal mines, but pumping that water out allowed miners to dig deeper and extract more coal. That new coal was then used to build and fuel even more steam engines. The steam engine functioned as the core processor of the new economy, turning raw subterranean fuel into unlimited mechanical motion anywhere on the map. Coal's thermal energy powered the heavy machines, and its chemical energy transformed the metallurgy used to build them. Britain had vast supplies of iron ore, but early extraction methods only produced a brittle, low-quality material known as pig iron. The crucial patch arrived in the 1780s when Henry Cort developed a process called puddling. In this process, coke, which is derived directly from coal, is used in massive furnaces to burn away the structural impurities inside crude pig iron. The process yielded high-quality iron, and British production boomed exponentially. Output accelerated even further by constant military conflicts in Europe and the colonies, which demanded a steady supply of heavy military-grade iron. This high-quality iron became the physical chassis of the era. It provided the strength necessary to build massive factory machines and soon an entire rail grid. Marrying steam power to high-quality iron birthed the locomotive. In 1804, Richard Trevithick built a prototype coal-powered steam locomotive that hauled 10 tons of iron ore and 70 people at 5 miles per hour. Better models quickly followed, leading to the next-generation benchmark, George Stephenson's engine, the rocket. The rocket could hit 36 miles per hour. In 1830, it was deployed on the first intercity railroad, a line specifically built to connect the factory town of Manchester directly to the port of Liverpool. This map of Great Britain traces the explosive scaling of that network. In 1840, Britain had nearly 2,000 miles of track. By 1870, a web of roughly 13,500 miles crisscrossed the country. The macroeconomic impact was immediate. Rail provided hyper-efficient transport for natural resources and finished goods, driving prices down while pushing sales and market expansion to record profits. It also forced a societal software update. The strict arrival and departure schedules of trains required the standardization of time, synchronizing clocks across different regions for the first time in history. The railroad was a networking technology that collapsed physical distance, fusing scattered regional economies into a single, highly efficient mass market. Inside the factories fueling this market, particularly in the leading textile industry, the human element was pushed to its breaking point. The legacy tech for labor was the cottage industry. Spinners made thread and weavers wove it into cloth, all from their own rural homes. The factory system completely decoupled this relationship. For the first time, the physical locations of home and work were entirely separate. Factory owners invested massive capital into heavy machinery. To maximize profit, they demanded those machines run constantly, producing at a steady, unbroken rate. This forced human laborers to abandon the seasonal rhythms of agricultural life. Instead, they were locked into strict clock-based shifts, performing highly repetitive motions. This new industrial discipline was incredibly severe. Adult workers were heavily fined for lateness and dismissed for minor misconduct. Child workers were often beaten or whipped just to keep them at their stations. The objective was total optimization. As one factory owner stated, his aim was to make such machines of the men as cannot err. By the mid-19th century, the system update began to spread, lighting up nodes in France, a unifying Germany, and the United States. To link its massive geographical market, the U.S. required a vast transportation web, laying down canals, steamboat routes, and 30,000 miles of rail by 1860. The primary driver of this American expansion was the Northeast's booming textile network, largely staffed by farm-sourced labor, predominantly women and girls. Production scaled drastically following Eli Whitney's 1793 invention of the cotton gin, a machine that rapidly mechanized the removal of seeds from cotton fiber. This bar chart visualizes the resulting data spike. In 1760, Britain imported 2.5 million pounds of raw cotton. By 1840, that number skyrocketed to 366 million pounds every single year. This raw output exposed a brutal input cost. The extreme profitability of raw cotton drove planters in the American South to rapidly acquire more land and enslave more human beings. The growth of the British and American textile industries relied on a foundation of forced labor. The industry's global success rested on the output of enslaved people. The Industrial Revolution required specific parameters: unlimited coal, high-quality iron, and tightly controlled global labor systems. But working at the map, why was Great Britain the only nation ready to process this massive economic level up in the 1760s?